Hello, friends, and welcome to the latest episode of our live stream series with some amazing guests from the Weddell Sea in Antarctica. My name is Chris Ahern. I am Director of Partnerships here at Reach the World, and I am so excited to check back in with my friend and colleague, Tim Jacob, who is on the SA Agolas II, beaming in live through the amazing power of VirtualExchange. And we'll be sharing with us some updates, some incredible stories, and he will also be sharing with us in a conversation with a truly special guest as we continue to speak with more exciting members of the expeditionary team. To date, we have spoken with the South African Weather Service. We have spoken with members of the White Desert, who are ice camp experts. On Monday, I was so lucky and excited to be able to speak to one of the stewards aboard the SA Agulhas II, and we have yet another really exciting conversation that we will be having today with yet another voice. So just as a friendly reminder, we are talking with an icebreaker in the Weddell Sea off the coast of Antarctica live. So Tim's signal may not be perfect. We may actually lose him if the ship shifts its direction a little bit, and that's all part of the excitement of virtual exchange. So if that happens, that's just more excitement. We also do have an on-camera classroom today, and for those of you who are joining us in the chat, please let me know if you have if there are any issues with. Please let me know if there are any issues with what you see, and also let us know where you're calling in from. And so with that, I do want to turn it over to my friend Tim. Tim, can you give us an update whenever you're ready?
Yeah, hey Chris. I am not able to start my video. Maybe the host could do it for me.
Let's see.
Hopefully you can hear me.
Yeah, I can hear you. Let's see if the host can.
Here it comes.
Oh, perfect.
Hey, hi everyone. Welcome once again to the SA Agulhas II here in the Weddell Sea off the coast of Antarctica. Very, very happy to welcome you to the ship again. The search for endurance beneath the surface of the amazing Weddell Sea continues. We have a couple more days to search before I think we'll have to be turning around and heading back to Cape Town. But for the time being, I'm very fortunate to be able to bring more stories from the ship to you. And we get to have a special guest today, Mr. Mark O'Reilly, the second engineer of the SA Agulhas II. And before we sort of turn things over to him, I'm going to ask him a few questions in just a bit about the way that this amazing ship works. He gave me an amazing tour beneath sort of the main decks of the ship to where all the things that help the ship run work. And I'm very excited to talk to him about that. I wanted to just bring you up to speed on two things. You can see I'm wearing these really cool snow pants today. It has turned pretty cold in the Weddell Sea over the last few days. In fact, actually the outside temperature hasn't changed much, but the wind has picked up quite a bit and it makes it feel very, very chilly. And these are special polar snow pants that are kind of insulated, and I wear them indoors now too, just because they're so cozy. Keeps everything from like here down really, really nice and warm. So that's why I have those on today. I just came back from outside very briefly today. As long as you're in sort of the wind protected area of the ship, it's not bad. But as soon as you go on the helideck or out onto the bow of the ship, the wind almost knocks you off your feet. I think they're saying we're up to 30 or 40 knots today, and you can really feel it. The second thing I wanted to share with you is that last night, right sort of before dinner, I believe it was, several of us were on the back deck of the ship on the helipad, again, looking down over the back of the ship. And there was a really amazing sort of nature scene popped up that I have to describe to you because it was so exciting. Straight off the back of the ship, there was a leopard seal, which for those of you who are not familiar with leopard seals, it's kind of rare to find this far south in the Weddell Sea. It is definitely one of the main predators of the Weddell Sea. So this big leopard seal, probably 6 or 7 feet long and a couple 100 pounds, was just sitting on this little ice floe. And then over here to the starboard side, from where I was looking off the back, there were some Adelie penguins, there were some emperor penguins, and over here there were some crab-eater seals. So there were like 4 species of Weddell Sea mammals right within easy view of where we were, and they were all just eye-locked on that leopard seal, because that leopard seal in an instant could have pursued any of them for a snack. We kind of thought we were about to have like one of those wildlife documentary moments where we saw a chase. But we didn't end up seeing it. The leopard seal swam away. It was just kind of neat to see that many different Weddell Sea animals in one spot. But with that, I don't want to really spend any more time talking about that because I have this great guest here today. Like I said, Mark gave me a great tour of the engine room and some of the things below deck about 2 weeks ago. And all of those pictures I sent and we published as an album on Reach the World's Journey homepage. But I'm happy to have you here, Mark, today to explain a little better about what those pictures show. So great to have you here. Thank you for joining me. Can you, first of all, sort of introduce yourself? How did you become a ship's engineer? Where are you from? Just tell us a little bit about yourself.
Okay, my name is Mark. I'm a second engineer on board Agulhas II. Started years ago. Always wanted to be in the mechanical side of things, so found my way on board the ships, and that's how I started and carried on and pursued the career. And everything fell into place. I went back to studies and got my certificate of my certificate for marine engineer, and carried on from there. And today I'm second engineer on board the ship.
I can tell you're condensing a long story because you are a second engineer. That's a pretty significant rank on this ship. It must have taken you a while to achieve that level.
It's a process, so it takes a while. You have to have your studies, your sea time, and all those kind of things, your practical component of it, and then you do your examinations, and then you move on from rank to rank.
All right. Well, I know you've studied a lot over the years, but this ship in particular seems to me very complex. Is this ship more complex than other ships?
From moving from the Agolas 1 to the Agolas 2, obviously the technology has improved and there's a lot of automation built into the ship. You gain your knowledge through experience and years working on both the ships, and you just progress from there.
Okay. Can you describe for us what your daily routine is like? What is an average day like for you?
Like today, I'll be going on shift now. So normally we're on a UMS system where we work during the day, and at night somebody will have the chance of looking after the machinery for the plant. And we are not in the engine room at night, but we have to attend to the alarms. The reason why we're on a watch system now is because there's a lot of movement in different modes and things like that, causing some alarms and so on. So it's very difficult to have a decent rest, and then we have someone in the engine room all the time. Okay. So if the breeze calls down, there's always someone to sort out any problems or requests or so, things like that.
Okay. Yeah, we've talked before about how this ship is running 24/7. There's never like a period where everyone's asleep and it's quiet on the ship. There's always somebody awake, yeah. And I'm happy to know there's always someone in the engine room, even though that disrupts the sleep. Yeah. So let's start with sort of like the basic part of a ship. What makes the ship go?
What makes the ship go? Yeah, we've got 4 diesel electric gensets on board. So on this ship it's diesel electric, and so we're producing voltage to drive the propulsion motors. Mm-hmm. So we've got about 16,000 horsepower available. Some of it will be for the accommodation, keeping the lights on and services, and the rest of it will be for propulsion.
Okay. So I've heard people talk about the difference between normal mode and ice mode. What is ice mode versus normal mode for the SA Agulhas II?
In ice mode, we've got your generators, and then producing voltage. We've got our converters, it's our variable speed drive converters, directing power to the prop motors. So in ice mode, we have 4, and 2 will be supplying the prop motors at maximum power. In normal mode, you'll only have 1 converter, which will limit your power output to about 60%. So that's your normal seagoing mode. It's more economical than your ice mode. Ice mode you need for breaking ice, so you need all that power on the prop. So that's basically the difference.
Okay. You told me something really cool about the propellers of the ship and what they do. Can you describe it for the kids?
Yeah. When we're in ice mode, also there's a selection where you select your constant RPMs. It will bring up your RPMs to about 140 RPMs, and it will limit your pitch, your angle of the blade, thrusting you forward to about 85%. And that will aid with chopping of the ice moving forward and back when we do get stuck. So it's just to strengthen the action or the blade going through the water and chopping the ice.
It had never occurred to me that the blades on a propeller could change. Then you can keep the shaft going the same direction all the time, right? That's very cool. So you talked a little bit about how the diesel engine makes electricity. That electricity is used to power the engines, but also power other things, right? Yeah. So the lights in this auditorium, the lights in our cabins, the electricity for the coffee maker, that's where that comes from?
That's where it comes from.
Okay.
So we've got our electrical network. Your high voltage will be stepped down through your transformers onto your 400 volt and supplying the rest of the ship, your big equipment, your air conditioning, your deck equipment. And then further down, it will be stepped down to your 220s for your plugs, lights, and things like that.
One of the things I like about this ship and this sort of international team that's here is that every plug you see, there's a different converter. Yeah. At least upstairs, there's the South African style plug with like a Euro adapter to a Euro plug, yeah, or to North America. All right, so let's move on to heat. In this very, very cold place, how do we keep this? Yes, sorry.
Sorry, I just wanted to pause there because this is such interesting stuff. I wanted to make sure that myself first of all, but then also our friends who are tuning in from all over the world. We have people who are tuning in from Brazil, from Allen, Texas, from Namibia, from all over, and so there's a lot of really cool terminology that we're hearing, and we just want to make sure that everyone can understand it. So you're mentioning some of the ones that I heard that I want to make sure that I understand are prop, which I think is short for propeller. So the thing that spins and actually either pushes the ship forward or in this case is essentially using like a giant blender to chop up that ice. And then bridge, that's where the captain and the officers are able to pilot the ship, correct? And then there's one other one that I wanted to ask about, and that is RPM. So you mentioned that there's a certain amount of RPM, and I want to make sure that kids know and understand what that means. So can you quickly define what RPM is?
RPM is your revolutions per minute, so that's your rotational frequency.
Okay, so when you're good. Miles per hour, sort of, but with how many times that is spinning per minute.
Okay, and so perfect. That's a good one. We're getting a ton of questions, so we'll keep you on your toes for sure, Mark. So let's learn a little bit more about that ship.
He knows all the answers to these questions. All right, I want to move on to heat. Yeah, we were going to talk about how we keep things nice and warm in here.
Yeah, so we've got our waste heat recovery system. It all comes off your heat from the engines. When we in ice mode and seagoing mode, when we're moving, we're actually moving and not sitting like we are now. At the moment, we're not generating enough heat, so we've got supplementary boilers coming online. So it will keep off your heat to the fuel. Basically it's a giant heat exchange process. So there's an oil circuit. Your engine gives the heat to the oil, and then through another heat exchanger process, we'll give it to the water, which will be used in the accommodation, heating up your shower water, things like that, even heating up the engine as well.
I like that. When we were doing our tour, I got a sense that that was just a very clever way to use all the products of that. You know, you burn some diesel fuel, but you make electricity, you collect the heat, you use the heat to heat other things. It feels very efficient.
Yeah, because in your exhaust uptake, your gas is going out. We could be when we're doing ice breaking or free sailing or things like that, we could be making up to 350 degrees exhaust temperatures. So going out, we've got all this waste heat. So we reclaim all that heat, putting it back into the oil circuit, and the oil circuit then in turn giving it to the water system. Where water system is cheap, is plentiful, and you can send it anywhere you like.
So the oil circuit is really just a pipe full of oil that kind of absorbs heat, and then you can transfer that warm oil elsewhere, run it next to like a water heater, and use that heat to heat the water for showers.
That's correct.
Yeah.
And also
very cool. Yeah.
That's the other part.
Good.
Actually, the most important part. If you don't have water on board,
right,
you're not going anywhere.
And that's actually next on my list. I think a lot of people have questions about fresh water, because I've mentioned before that we have been asked to sort of conserve water since we're not moving much. We move like once or twice a day, but not very far. And the ship can't produce enough water to like do laundry, do showers, it's doing fine, but it's not like you can't have as much as you want. So how does the ship turn salt water into fresh water?
Yes, our desalination system is basically a unit where you draw a vacuum in the unit and you can boil water at low temperatures. So your seawater coming in will be boiling around 40 degrees or something like that, and it will turn it into steam, and it will condense. And obviously your heavy salts gets taken away through your process at the bottom, and your steam will collect, and your condensed water will be drawn off on the other side, and then that would be your fresh water. Will end up in a tank, and then through your rehardening filter, putting some of the minerals back and into your tank. From your tank, it gets pumped into your accommodation area where you'll have your water in the taps and so on. Just to make it taste a little better, we've got these fountain filters, so carbon filters, to make it taste a little bit better, because it is evaporated seawater. So yeah, and then up to your cabin.
So why, when we're standing still, can we only produce like 20% of the capacity that we can when we're moving?
Yeah, so it's a process where we need the heat to boil the water. In the freshwater generator, it uses the waste heat, and when your waste heat temperature drops, your production drops as well. So at the moment, when we like this, we can make about 25 cubes a day, 25,000 liters of water per day. But unfortunately, we have everybody on board and people use water. So our consumption can go up to about 30,000 liters per day. Wow. Yeah, so it's not raining and we have to make it. So we don't have the heat on board to get the output on the machines. And yeah, so we have to kind of conserve and do things like that. When we normally come down to the Antarctic, we have 60% of the people getting off the vessel. So we don't normally have the problem or this issue where we need to conserve a little bit more water and be more efficient. So yeah, that is why we have some of the restrictions in place.
So you're normally bringing people to the research bases in Antarctica, and they get off, and then you have plenty of water for the people who are left. But we've been sticking around and taking hot showers and all those things too long.
It's all your creature comforts. People like to have a shower, after your shift and things like that.
Yeah.
But be okay.
I am so fascinated with with this process. I think it's so interesting. And full disclosure, before we started the live stream, I was actually saying that it was myself and another member of the Reach the World team who were really interested in how this all works. This process that's known as desalination, or removing the salt from salt water. And so essentially what you're saying, so I want to make sure that I get all of the processes correct. So number one, the water gets sucked on board and then it gets put into a vacuum, which means it gets put under pressure. And because it's put under pressure, it boils at a lower temperature. And then once you boil, you're turning it into vapor, and then that's the place, because the salt sticks around, it doesn't get boiled off. And then you're able to just collect the fresh water off of that, and then you just put it through a carbon filter, just like what we have as like a Brita pitcher at home or something like that. And that's just because you want to remove a few more of the minerals that seawater tends to have, but not the stuff that we typically drink, right?
That's correct.
It's pretty amazing. And this ship, when we're holding still, can make 30,000 liters a day, or no?
It's a little bit less than that. It's a little bit less than that. Yeah, we would hope to make 30,000. Then we won't have the restrictions in place.
Well, I mean, that's pretty cool.
I mean, I was going to say, I think that this is a really good conversion math assignment for some of our classrooms out there. So if the ship can in peak condition create about 30,000 liters today, since we are in America and we do not use the metric system, let's convert that meters into how many gallons per day could that be. I think that's a fun math activity for everyone to do, and I see Mark doing the math in his head right now. Tim, is there any other parts of the ship that you wanted to go over before we jumped into questions?
Definitely are. There's three more that I want to touch on, and I know this is going to be of interest to a lot of people because I've heard questions about it before. This ship has its own wastewater management. So we talked about making the water we drink and the water we use for cooking and washing and all of that. And what about like the water after we shower? It goes down the drain. What do we do with the dirty water?
Yeah, what goes up must come down, I guess.
Yeah.
So we give you nice clean water, and then from the accommodation range, your scuppers, your showers, all those kind of areas gets collected back into a grey water tank. Obviously, grey water and your raw sewage is separated. So your grey water will be in a separate tank, and your sewage will be in your sewage processing unit. So from there is your biological process, and then it moves to filtration. So you've seen the water coming off the unit. It's crystal clear. Yeah. It looks like drinking water. If you put it next to a glass of ordinary water, you won't notice the difference easily. So that's how efficient it is. So the grey water will be put into your sewage system because it's a vacuum system. It uses very little water, so we have to keep the process liquefied. Otherwise, you'll just have too much of product. And then through that process, feeding all the grey water into it, we can move it through the system and then clean it up before we put it over the side.
And with the sewage, with like the stuff that goes down the toilet, like what happens to that? Because you can't dump that. You can't. Yeah. What do you do with it?
We collect everything on board. Our parts of the raw sewage that does not break down, like the grains and stuff. The system takes care of itself basically. It desludges as you set the time. So you can desludge it into a spinning unit. It's basically removing all the dry particles from the things that cannot break down easily. So it removes it from your process, and then it stores it on board in another tank. And that tank we empty out maybe once a year. So the system is very efficient. Yeah. We are allowed to put it over the side, but not in a special area, and we must be moving. Okay. And we have to log it as per clean design.
I thought that was absolutely amazing for this ship, which operates year-round.
Yeah.
And there's sometimes as many as 150 people here using toilets and making all sorts of waste. You only have to like the biological process filters and cleans out the water. Yeah. But what's left, the residue, the sludge, as you called it, is like only needs to be emptied once a year. That's amazing. It's very self-sufficient.
Yeah.
Cool. All right. I'm sure we'll have more questions about that. But I wanted to, as a sort of a final area, talk about ballast, because people who don't know much about ships may not know what ballast is. And you showed me on, Mark works in this very cool area down below deck that has computer screens everywhere. Everything is very digitized. And you showed me, I think we were down there when we were underway in the Southern Atlantic, and you showed me a graph that had these lines that were kind of going like this.
Yeah, that's great.
Yeah.
That's also a system because we're an ice class ship, we don't have the fins, the protruding fins, because that will only get damaged in ice conditions. So we have the water on board where the water will be transferred from tank to tank through giant tubes. So they use the free surface of the water to kind of dampen the rolling effect.
Okay, so using that abundant resource, there's plenty of ocean water here, take some into a special storage area in the ship, and then use the weight of that water to help balance the ship and keep it from rolling so much. That's very cool. And finally, one last thing I have to ask you, for anyone who saw the album on Reach the World's Journey page, there's a really great picture of a board that has some tools on it, and one of the tools on it is like a bright golden hammer. And when I saw that, I had to take a picture of it because it looks like the magical tool. Like anything that goes wrong in this hold with all of this complex machinery, like in my mind, I'm not a mechanic, I was like, oh yeah, you just give it a whack with the golden hammer. Is the golden hammer the magic tool?
No, it's not. We would like to think of it as the magic tool. That's actually part of our fuel and oil cleaning process. It's an ongoing process. So the hammer is used to open up the machine.
Okay.
Yeah.
All right.
So hopefully we don't get to use it often.
All right. Very good.
Yeah.
Not as cool as what would happen in my head, but a very practical answer.
Yeah, I was hoping that you're going to say that this is the secret location of Mjolnir, Thor's hammer, but we will have to still continue to look for that. I did want to mention that some of the questions, some of the things that you're telling us about wastewater and about the about how you hold on to the waste that comes off the ship and the efficiency. That was actually a question from one of our teachers, one of our classrooms in Allen, Texas. And because she was asking, what do you do with the water? What do you do with the wastewater? How do you hold on to it? And so like you're already answering the questions that our classrooms are super excited to know. So thank you so much for doing those. And before we bring on our live classroom, I did want to ask one more of these questions. So this is another question from all the way in Allen, Texas. And so this question is so I'm actually going to combine these two questions because I think they're really similar. So number one, if one of the engines breaks, if one of the engines breaks, do you have the parts to fix it? And then similarly, does ice or the cold do damage, or can it do damage to parts of either the engine or the propellers themselves? So sort of if like, what happens if something gets damaged, and how do you prevent that damage from happening? I think would be how I would streamline that question.
Yeah, so on board we're supposed to be, according to your ISM, you're supposed to have a certain amount of space that you need to carry on board for repairs and things like that. In this ship, we have, if you're not in the ice conditions, you've got 4 engines, and we normally only need 3 as per the default setting for our seagoing mode and things like that. We can go down to 2 if we need to, depending on the load and the sea conditions. So we do have enough spare equipment and parts on board to actually do a repair on board.
One of the things I heard too is that many ships have like a copper propeller or like a pretty propeller, but the SA Agulhas II has a stainless steel propeller.
It's if you look at the prop design and the size, compared to normal ocean-going vessels. Our propeller is very short and stubby, built strong for the ice conditions. So it's made of stainless steel, and that's why we have your RPMs increasing to about 140 and turning the pitch back so that you have that giant like a blender, ice chopping out. It gives a stronger profile to the blade chopping the ice, because you don't want to open up the blade too much and you can cause damage.
And if it goes without saying that if we damage the propeller, well, where we are right now, we'd be in trouble.
We'll be in trouble. Yeah. There's no fixing outside equipment, not in the icy conditions.
Right.
Well, I think that's really interesting, and I think it's so interesting. And this is something that we've heard from a lot of the other members that we've been able to speak with of the expedition, and just about how there's such an attention to detail, and that it's not just about making sure that we have a backup plan, but that we have 2, 3, 4 backup plans, and then we have the break glass in case of emergency one. Maybe it's the golden hammer backup plan if all else fails. But it's just so important because we want to make sure that everything is taken care of and that we're really thinking ahead. And I want to make sure to impress upon our classrooms that are watching this, as well as in the future, the importance of doing that. That this is something that I know as a former teacher. Tim, you as a former teacher, we say and said all the time to our students that it's like we need to think about what is it that we need to do. We have to think ahead. We have to make sure that we have backup plans and be thorough in how we're approaching our projects. And this is exactly how the SA Agolas is so successful at what you do, is because you have so much good planning that's going on. So I do want to bring on our.
Chris,
sorry.
There's 2 things I want to add to that. One is that the ship has, and this is a big word, redundancies everywhere. It has backup plans, and I think that's what you're just sort of describing. And the second thing is that people like Mark and his colleagues know every inch of this like maze of machinery down underneath the deck. And when things break, they understand. You can identify quickly what's broken and fix it. And so spare parts are great, but knowledge and understanding of the systems is really important too.
Wonderful. I love that. Redundancy is one of my favorite words, and I know my colleagues here at Race the World know my love and appreciation for that term. And so I do want to bring on our live stream classroom to see if any of these students have. This is a special classroom because we are tuning in with all the way to Luderitz, Namibia, where a fairly new school is getting started, and so we have 3 students from that school. It's 6 p.m. there, so this is definitely after school hours, and so Lucy, do you have a student who might want to ask a question?
Yeah, Amanda, do you want to start?
Yeah. What are the risks that you have to look out for in the boat?
Yeah.
Repeat your question, please.
Repeat it. I don't know.
What are the risks that you have to look out for in the boat?
What are the main risks?
The risk, when we do ice navigation, it's normally up to the people that's got the eyes on top in the wheelhouse, in the bridge where they steer the ship. That would be big giant icebergs and things like that. So that's mainly the things that we need to look out for. And obviously, some of the weather conditions makes it very difficult to navigate. Sometimes you'd have a whiteout where you have snow and it makes the visibility, it's very difficult to navigate. And as well as where we are now, you can see that our day and night is getting longer, the nighttime parts, and we have to basically drive the ship with the lights on. So normally that does not happen when you're out at sea. So those are the things that you have to be aware of.
Ready?
Good question.
How how much does the ship weigh?
The ship weigh, if I remember correctly, it's about 12,000 tons. I don't know what system you use, but it's about 12,000 tons.
That's
Pretty
actually
big, right?
And for everyone who's trying to think about what is that, a ton is about 2,000 pounds, at least in the English system that we use here in the States. So think about multiplying each ton that Mark was just mentioning by 2,000 to get how many pounds. And I think I have to ask a follow-up question to you, Mark, because when we talk about ships, we don't just talk about how much they weigh, but displacement. Do you happen to know the displacement of the SA Agulhas II?
I'm not sure. I'm not sure on the number.
I know I'm putting you
Somewhere
on the
around
spot there.
a
Marcus,
lot of
do you
blue
want-
whales.
Do you want to ask a question? Marcus is a very keen animal spotter, and we love the story of the leopard seal. We were wondering, are there any other cool animals that you've seen in your time at sea?
Some whales, mostly penguins and seals, some whales, yeah, and some of the bird life. There's no polar bears down in the south, so no polar bears on the side.
Well, from what I've heard, the leopard seals are the things to definitely watch out for. Tim, as you were saying that story, I was thinking about the story Endurance by Alfred Lansing, which we've referenced before on this live stream. And there's a really famous story of one of the members of the Endurance crew that was off a little bit from the ship before it had crushed. It was just stuck in ice, and all of a sudden he sees he's off on his own, and he just notices this massive spotted creature just coming lumbering toward him, teeth fangs bared, and he had to pull his rifle off of his shoulder and defend himself at the last moment. And then it turned out that it was a good thing, because then they had all of this seal meat and blubber that they could use for to keep themselves warm and fed for the next few days. But they're from what I've read, they seem pretty scary creatures.
They're awfully fun to watch from the safety of a helicopter pad on the back of a ship. It was kind of like our own live nature documentary unfolding right before us.
Wow. Manny, another question?
Yeah. How fast can the boat go?
How fast can the boat go? 3 miles we can do. I've seen 22 knots. This is 1.6 miles per hour. What is that in
22 knots. It's not, for those of you who are going to measure this by how fast a car can go, it's not going to seem very fast. But on the ocean, when you're making a ship of this size move, it's very fast. And I don't know the calculation in my head. I have to do it online. I'm sure Chris is doing it right now. But it's pretty fast. I think on our way from Cape Town to the Weddell Sea, we maxed out at about 18 knots.
Just over 18 knots.
And we were moving pretty fast. Yeah.
We went out on a small boat yesterday, just so the kids have something to compare it to, and we were going 7 knots. That's what we were doing on the whale rider yesterday. So they're going 3 times faster than what we were doing yesterday in a really big ship.
Yeah, it's around about 30 miles per hour.
Yeah.
That's must feel pretty fast. And in the ice,
It's much slower than that. We'd have to, yeah, we can't be bad ice at top speed, so we have to slow it down and let the maximum power on to break through the ice.
Yeah.
Also, though, I mean, this is a very easy thing to understand that you need to slow down for, but we did have to slow down when we hit some big ocean swells, because the pressure, the impact of those big ocean swells on the side of the ship causes strain on the steel, on the hull, and on the engines too, and I think can make it overheat if you're battling against the water like that. So we did slow down when we hit some storms in the South Atlantic, but we made really good time getting here.
The ship comfortable, so everybody comfortable sleeping and making it safe.
I mean, I think that's pretty impressive because
boat that big.
yeah, I think it's pretty impressive just because I mean I grew up pretty close to the ocean, and I spent a lot of my childhood and early years on different ships and boats, and I can count on less than one hand the amount of times where I was going 22 knots or thereabouts. And so that's pretty impressive. I did want to mention a couple things that are just coming from the chat, which is number one, that someone mentioned that according to their math, the SA Agulhas II weighs about the same as 10 or so blue whales. I like this conversion. How many whales does a ship weigh? So I think that's a pretty good fact, and I'll need to do my own fact checking on that afterward. We also have a couple other questions that I wanted to make sure that that we could have you answer. Number one, when you're pumping in water for the desalination, also for the ballast, we have one classroom that wants to know, are you sucking in a lot of the sea life, the krill and some of the other smaller fish that might be there, or is there some way to prevent that stuff from getting sucked in?
That is when we in deep oceans, there's not many sea creatures that we suck in. No, I haven't found any. Sometimes we do get where you move through a patch and you might suck in some of it, but it's minimal.
You then pump it back out.
It gets caught in our filtration system before it goes through our coolers and things like that. So. Okay. It creates a problem for us, so we have to remove it physically. Otherwise, we have overheating of the engines and things like that.
I've also heard story from other people who are in sort of the marine biology industry and whatnot, that this is a challenge, that when a ship sucks in ballast water, especially if they're in an area where there might be very, very small, sort of babies of larvae of different sea creatures, they may suck them in one place and then be traveling thousands of miles to another, and then they're pumping out their ballast water. They don't realize that they have those things on board and are introducing those species. So it's definitely something I'm sure that you and your colleagues are always thinking about. I have one more question before we go back to all the way to Namibia through the power of VirtualExchange, and that is, so you're pulling all this salt out of the water. What do you do with it after? I don't think it goes to the kitchen, does it?
No, it doesn't end up in the kitchen. That's part of the byproducts of your desalination. It just gets put back into the sea. So normally we would have a seawater recirculating system where some of the warm seawater that we produce from cooling the rest of the plant, it gets put back into the seawater to maintain a certain temperature, and that part of the desalination process goes overboard at the end of the process, so it doesn't come back to the cooling circuit.
Interesting. It's so complex. Every time someone asks a question, we get a little bit more of this, like how amazing your job is. All right, let's come back to Namibia. Lucy, do you have any more questions?
How many layers of steel is the outer boat made of?
The layers of steel with the ice class ship, you've got varying thickness of steel as the hull from the bottom to the top, and then also because of our ice class, tanker class, all those kind of things built into the design of the hull and the vessel, we've got two layers. It's a double hull system. So obviously we're not throughout. We'll have different void spaces along the hull of the ship on the waterline.
So I've heard it said before, maybe this will help also answer your question, that this is a class 5 ship, right? Can you explain what that means?
It's a different class, so you obviously have your different strengths of ice breaking capability. So this would be your class 5, and obviously your bigger, your more powerful, more thicker ships can have more capabilities moving through the ice and so on. Yeah.
So the hull that the Agolas II has is very, very strong, but it has a limit to the thickness of ice that they attempt to break through. I think it's just a couple meters, right? But a couple meters is a lot of ice. When you see the ship moving slow, I mean, lots of ice, thicker ice than I've ever seen. But there are ships that have stronger engines, that have stronger steel, just stronger design that move all the way up to class 1, right? Which couldn't just go basically anywhere it wants.
And obviously with that, you burn lots of fuel.
Right.
So,
Right. So the Agolas II is a polar research and resupply ship. It's not technically an icebreaker.
I would say it's an icebreaker. It's a different class of icebreaker.
Okay.
So that's why you have a different class.
Got it. There's
How does
stronger
that
ones out there.
compare to the Endurance? What would have they had by way of ice-breaking capabilities?
Yeah, we had that's a good question because we had that yesterday. We were talking to some like ship designers who were talking about that difference, and they said the major difference between the Agolas and the Endurance is that, of course, the Endurance was made out of wood, and it was made out of the strongest wood available at the time, but it was still wood, and the steel hull of the Agolas is significantly stronger. I don't think anybody's really worried about the steel. It's closely monitored on this ship. I've been very impressed to see, through Mark and his colleagues and also some of the scientists on board, every time there's a bang or a scrape to the side of the ship, it's being recorded and it's being analyzed in a very scientific way for future ship design and also just monitoring the day-to-day health of this ship. So there's always someone awake with you, or not, like maybe not in the engine room, but up on the bridge when we're moving through the ice, making sure that we're not trying to break through ice that's too thick for this ship.
Yeah.
And
some of the voices will have your water content in there will set up an alarm.
Okay.
And that actually was just the last question I wanted to ask. That this is something that I know you mentioned at the very beginning of the call, but I wanted to get a little bit more go a little bit deeper on, just because I think that what you do is so fascinating, Mark, and I know I have friends and former classmates and colleagues who are engineers, but specifically you've done a lot of very special work to be a ship's engineer. And so I just want to know a little bit, why did you choose to pursue to become a ship's engineer rather than, let's say, an engineer who works who works here in New York City, helping to ensure that buildings are safe against the wind or something like that? What made you want to become a ship's engineer?
Not really sure. I think it was just part of my basically my father was at sea, so in some way I suppose it also rubbed off on me. So my brother was at sea for a short while, and then obviously that's where life took me, and I like being at sea, engine room specifically. So they always ask me, what are you doing down here? What are you doing down here? I'm always down in the engine room.
Do you have a favorite part of the engine room?
That's my home.
Yeah.
That's my home.
Yeah. Where the actual engines are stored.
Yeah. During the day, even at night, I would, we've got our facilities upstairs, but I would go down and do my laundry in the engine room. I would go down and have coffee in the engine room, even at night. So that's where you'll find me.
It's hard to describe what the engine room is like. You'll see the pictures in the album that we're sharing in the chat, but we had to wear ear protection because it's very loud. And most of what Mark was explaining to me was done with hand gestures, like just trying to signal what's happening. So it's been very helpful for me and for all of us to hear from you how those things work, because the engine room is a loud place, but I can see why you'd find it comforting, because there's kind of a constant whirl of noise, and when everything's working well, it's very impressive place.
It sounds it, and I love being able to hear you talk about how it's just something that's clearly a part of you, and I think it's really great for the students that we have. We have over 1,000 classrooms following us from all around the world. Be able to see that passion and that excitement for the work that that you're doing, and how it's really something that's a family affair. So I wanted to. I wanted to just quickly thank you all, thank our guests who are joining us live, our guests who will be joining us in the future, for joining us today. We do need to wrap up, and so if you have any other questions, you can always reach out to us through email, through all the different messaging. So thank you both for coming. I also see Celie in the background. Thank you, Celie, for continuing to make sure that you're available. I also, before we go, I did want to give a chance to allow for our wonderful on-camera friends who are joining us all the way in Namibia. I do want to pass the mic over to you, so that way you can give one last big thank you to Mark and Tim and Celie and the rest of the crew aboard the SA Agolas II before we wrap. So over to you, please.
Thank you.
Thank you.
Thank you very much. That was absolutely fascinating.
Especially about the boat.
Excellent question.
It's amazing to think of you guys. We're looking out to the blue. We can sort of imagine you all the way out that way. It's an incredible thing you're doing, and we love following you. And thank you very much for arranging this and making the time to talk to us and sharing your passion and enthusiasm.
Absolutely.
You're welcome.
And
we'll be heading back your way soon.
Yep, exactly. And we're so excited to be for you to be here. And again, thank you, Tim. Thank you, Mark. Thank you, everyone. We will be back tomorrow to be speaking with some cadets and hearing a little bit more of a younger voice aboard the ship, to be able to hear, again, more of these amazing stories about not just what it is that gets people super excited to be a part of this expedition, the amazing jobs that they're doing, but again, to answer those stories about why is it that you're doing this and how did you get there? And so we can follow in your footsteps. So with that, we will call it for today, but we will be back. We will be back tomorrow, and with more updates, more excitements, and more stories. So thanks again, everyone, and have a great rest of your day.
Thank you very much.
Bye-bye.
Bye. Happy hunting.
Thank you.